Hi. Our last unit that we're going to do this year is going to be on probability and statistics. So we're going to do a brief unit on that before we end the year. So the first one is just kind of refreshing your memory on probability. So hopefully a good chunk of this is review, but first of all, what is probability? Remember that probability is simply the likelihood that an event is to happen or occur. So when we think of probability, we are thinking of anywhere from 0 or up to 1. Now this could be written as a decimal, fraction, or you could also write percent. Then it would be from 0 to 100%. And the closer you are to 0, the less likely it is to happen. The closer you are to 1, the more likely it is to happen. Okay? So probability is all around us. You'll see this in lots of different aspects of our lives, but just on your phone, there's an app that tells you the percent chance it's going to rain. You can see that on the right. There's Powerball, Mega Millions, games all deal with chance. Sports, your insurance companies figure out what your chances are of getting in an accident, how long you're going to live based on certain factors, all kinds of things like that. So probability is all around us, whether you are aware of it or not. So how do we find probability? Generally speaking, the way we find probability is the number of successful outcomes over total number of outcomes. So basically successful over total. And when we're thinking about writing probability, if you're trying to say the probability that it's going to rain, you might write probability like this and then rain. So this is just kind of a notation. So this would stand for the probability that it would rain. Okay, so let's try some just kind of ones to get you back into the swing of things. So for example, let's say we have each letter of a word, the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? So, whoops. Let's say we're trying to find a consonant. And first, remember, we want successful over total. So in this word right here, if each letter is written on a card, there are 1, 2, 3, 4, 5, 6, 7, 8 letters there. So that's the total. And a consonant, if you remember, is anything that's not a vowel. So we have P, R, B, the other B, and L. So 1, 2, 3, 4, 5 of those are consonants. So the probability that this would happen would be 5 out of 8. Whenever you do probability, you always want to ensure that it's, if you write it as a fraction, it's reduced. So in this particular case, you might want to pull up your calculator and just test. So you can either write it as a reduced fraction. And remember how we make sure it's reduced is you're just going to go 5 divided by 8, hit math, and then the top one should be changed to a fraction, press enter, and you get 5/8. That's reduced. So you can write 5/8, or you could go and write it as a decimal. If we do decimal, we'll probably round it to 2 decimal places, somewhere in that neighborhood, always at least 2. So you have you could say 0.63 here, or you could write all 3 of those since it ends. So you could say 0.625, or you could write it as a percent. So this I can either write this as my answer and leave it because it's reduced. I could write 0.625 or 6.63 if you'd like. Or you could write, remember you could write this as a percent by moving it 2 places to the right. So any of these 3 are okay when you're doing probability. If you decide to use the fraction, it has to be reduced though. So that's kind of the one catch, okay? All right, so here's another one. Sometimes it's important to read these carefully. So the probability that it will be sunny tomorrow is 7/9. What is the probability that it will not be sunny? So when we're thinking about total, it's always going to be 1 or 100%, depending on what you're given. So if we know that the probability that it's going to be sunny is 7/9, I want to take that away from the total. So total would be 1, also known as 9/9. So if I take that 7/9 away from 9/9, I'm left over with 2/9. So this would be the probability right here that it's not sunny. And that is reduced, so I could leave it like that. Or if you want to put it in decimal form, that's fine. So hopefully that makes sense. But just kind of when you're looking at this, be sure you're looking and reading carefully. All right. So now just starting to get into a little bit more ones that you got to be a little bit more careful with, a little bit more challenging. Still not super tough, but 2 number cubes are rolled here, and all the possible outcomes, that's the sample space, are shown right here at the right, okay? So what is the probability that when you roll these 2 numbers, you get a sum of 8? Now, a sum again means if you add the 2 numbers together. So we want to find all of the ones that we get an 8. So that would be 4 and 4, 5 and 3, 6 and 2, 3 and 5, and 2 and 6. So if they go the other way. So there's 5 there. Out of, there's 36 total there. Now again, you want to try to reduce that if you can on your calculator. In this case, that's already reduced, or change it to a decimal if you'd like, or a percent. So that would be the probability that you get a total of 8. So, okay, how about a difference of 8? In this case, so difference, remember, is subtraction. I'm going to erase these here. And what's the probability that the difference between the 2 number cubes is 7? Well, in this particular case, the biggest difference I have right here is 5. I can't get up to 7. There's no way I can do that with what I have here. So the probability that this is going to happen is 0. That's never going to happen based on these 2 dice. Okay? All right. Quickly, a couple of other ones. So using a table, what is the probability of getting a 4? If you see this, you know that a successful outcome would be getting a 4. How many times does that happen? 14, based on this experiment. Now remember, with probability, the bottom number is your total. So what you want to do then is take those numbers right there, 6, 11, 19, and 14, and add them together, okay? And in this case, that would give us 50. This is not reduced, so you either want to reduce this to 7/25, or you could change it to a decimal, which would be 0.28, or you could write it as a percent, 28%. Okay? So any of these 3 are okay, but don't leave it like this one. Okay, so what is the probability of not getting a 2? Well, we know the bottom is 50. And everything that's not a 2, sometimes that's the easiest way to look at it if you have all that information. So that would be this one, and this one. You could add those together, or you could also take away 11 from 50. Either way, you're going to get to 39 out of 50. So again, you can reduce that if you'd like, or you can change it to a decimal. I'm just going to reduce it, and that is reduced already. Okay, so that's that. So then the only other kind of problem that you're going to see that might be a little bit weird is something called geometric probability. And so the probability stuff still remains the same. It really is, you're still finding the total on the bottom. And in this case, the total is going to be this whole area right here. So that's a square. It's 9 by here, that's also 9. So 9 by 9 is 81. So 81 square centimeters there. Now, to find the area of the shaded region, which is what we're trying to find, we need to basically take this triangle right here and then subtract this chunk out of that. Okay, we got to take that out. So to find the area of the triangle, remember that's 1/2 times base times height. Okay, so this would be 1/2 times the base, which would be the bottom. There is 9. And then the height would be this distance right here. And notice that's the same as this. So that's also 9. So that's 1/2 of 81. So you should get 40.5. So that's just for the triangle. So the next thing we want to find is this little rectangle here in the middle. So remember, that's just base times height for a rectangle. So that would be 4 times 3, which is 12. So now I want to subtract this number and this number. Okay, so 40.5 minus 12 would give me, 28.5. And then just because that's kind of ugly, it's maybe best to just divide that on your calculator and change it to a decimal. So I'm going to do that quickly. 28.5 divided by 81. We get we're going to say 2 decimal places, so 0.35. Okay, so the probability of landing somewhere in that shaded region would be 0.35 or 35%. Okay, so that's a review on probability. Hopefully a lot of that makes sense and comes back to you pretty quickly. All right, see ya.